All right, hi there. This is video number 13, and it is chapter 3, section 6, and it is all about solving quadratic inequalities. And then we are going to also, after we do that, we are going to graph these on the number line. So remember, with an inequality, you're talking about less than or greater than, or less than or equal to, or greater than or equal to. And on the number line, the less than or greater than get represented with an open dot on the number line, and the greater than or equal to, if they have a line under them, those get a closed dot on the number line, right? So that's just a reminder. Also remember, I don't know if this is actually going to happen, but remember that if you multiply or divide an inequality by a negative, you need to flip the inequality symbol. So just a reminder, like I said, I don't know if that happens. There are a couple things that are going to happen in varsity, though, that you need to be aware of. And we'll talk about those when we get there. It's all about the inequality notation. So that's just the answer to the problem, like x is greater than or equal to 6, right? So that's inequality notation, but it gets a little bit more complex for these problems. So let's take a look at these. We'll do 3 or 4 examples, and then you can head off to varsity and work on that. All right, so the first one looks like this. Solve and graph x squared plus 6x, that's a plus 8 is greater than 0. Okay, so we're going to factor these. I think all of them are factorable. So just kind of ignore this and make it an equality for now, I suppose, and we'll come back to that at the end. So we're going to solve with x methods. We have 8 and 6. Well, that's going to be 4 and 2. Our a value is 1. So we're just going to get x plus 4 and x plus 2 is greater than 0. All right, well, what you're going to do here is, like I said, pretend that this is an equality. So set these equal to 0 and solve. And then I want you to plot these on a number line. And when you do your assignment, I want to see these number lines on your paper. Don't just throw them into varsity and I have nothing to go off of if you're having some problems. So draw yourself a number line, put them the lowest number first, and then the bigger one. And then they're both going to get what kind of dot? Well, the dot depends on the sign. And so these ones are going to get open dots. So there's going to be an open dot at -4, open dot at -2. Well, now you need to test a value in each interval, essentially. So we're going to test something in here, test something in here, and test something in here. And if it's true, you're going to shade that area. And if it's false, you're not. So I'm going to actually test -5. -3 is the only whole number between those two. And then I'm just going to do 0 over here. So what we're going to do for these test values, let me actually do these in different colors. We'll do the first one in purple. So we're going to test x equals -5. And by doing that, we're just going to take the original equation and see if we get a true or false statement when we put that in there. So we have -5 squared plus 6 times -5. And I'm going to write this all out at the beginning, but then as I do them, I'm just going to start taking shortcuts a little bit. So this is 25 minus 30 plus 8. 25 minus 30 is -5. And 3 is greater than 0. And this is true. And that was for -5. So that means this part below the -4 is going to get shaded. And those will all be solutions. That makes me believe that the middle section will be false, but let's go test it. So we'll do that one in yellow. We'll test this one in yellow. So we're going to test x equals -3. And again, x squared plus 6x plus 8 is greater than 0. If x is -3, then this is a 9 minus 18 plus 8. 9 plus 8 is 17. This is -1 is greater than 0, and this is false. So this would get no shading. Right? If it's false, you're not going to shade the section that came from. Then I'm going to test the far right-hand side. We'll do that in red. So we're going to test x equals 0. Again, we have x squared plus 6x plus 8 is greater than 0. Well, if x is 0, these go away. So I have 8 is greater than 0, and that's true. So we shade. Everything bigger than 2 is going to get shaded. Okay, so I want to see all that on your paper, these tests, everything else. I'll just make a note here that you're going to shade. And then let me show you over in Varsity, they're going to have that. And they're also going to ask you for inequality notation. And so you need to, the inequality notation is the math form of the solution set on the graph. Okay, well, if you take a look at this graph, I'm going to erase this part in yellow up here. You've already got that on your paper. I just need a little bit of space to write. So I'm just going to get rid of this for a minute here. And go back to this. Okay, so we want to write the solution for this. So this part, we know that x is not going to touch -4, but it's going to be everything less than that, right? So x is going to be less than -4. And there's a break in here, so we have the word or. And then we have x is bigger than -2. All right, so this would be the inequality notation for that in Varsity. We're in chapter 3, section 6. So let me go. It's not going to be the same problem, but I'm going to show you where you can go do these. Varsity. Okay, so we're going to go to Algebra 3. Hang on, it's thinking. Okay, down to chapter 3. I've got that open, and we're in section 6. Quadratic inequalities. Maybe I'll get lucky and the problem will actually be the same. Wouldn't that be crazy? Oh, it is. Look at that. So that's the one we just solved. And so we said we're going to have open dots at -4 and -2. So you put your open dots on there and then select your line tool and just drag it all the way to the end. It'll automatically make the arrows on the end for you. Okay. And I would, if you have unlimited attempts, I would go ahead and graph that first and then submit it. And it's going to say, hey, you didn't answer the whole thing. Are you sure you want to submit? Yes, I do. I want to see if that graph is right, because if the graph is right, and it is, then it should be easy for you to actually write in your inequality stuff. So I don't have a keyboard attached here, but if I click in here, there's a couple ways you can do this. You can just plain old type, or you can go to the equation editor and you see this tab right here that says inequalities. So you can click on that, and then you're going to have to type some things, but it's got your inequality symbols, it's got your or, it's got all real numbers and D and E. So I'm going to put in here x is less than -4. I need a keyboard. Is one going to come up? Okay, so x is, oh, I actually want a lowercase x. X is less than -4. -4. And then you can just hit the or you can literally no spaces and just type the word or, which is what I did when I did these longhand. So I'm going to click the or, and then I'm going to go, I need my keyboard to come back up. Come on. Okay, so now I need x is greater than, and I can just go here, greater than, oh, it didn't put it in there. Interesting. X is greater than, it doesn't want to do that. It is not cooperating. Greater than, this is stupid. It irritates me when technology doesn't work right. Maybe I'm not being patient enough. -2 I need in here. Okay, so we're going to save that. Notice it puts it over here. It writes what that inequality notation looks like. And we're going to submit that answer. It's thinking. And you're going to be good to go. Okay, so that's how that's going to look over in Varsity. Let's just do another couple problems just to see how this might look if you do a different type of problem. So let's solve x squared minus x is less than 30. Now, make sure that this is in standard form before you begin, which means it's got to be equal to 0, right? Or less than or equal to, less than or greater than 0. So we need to move the 30 over, making it negative. So we have x squared minus x minus 30 is less than 0. That's going to x method into x minus 6 and x plus 5. We're going to set these equal to 0. And then we're going to plot them on a number line. So I have -5 and 6. We know that because of the symbol up here, the inequality symbol, these are going to be open dots. Again, remember, they're only closed dots if you have those. Okay, so now we need to test, test, and test. Now, typically, you're going to have this as a graph. You're either going to have the edges, if there's only 2 dots, the next one has more than that. You're going to have the edges graphed, or you're going to have this. So you could actually do a little shortcut and only test the middle section, because if it doesn't work for the top one, then you know that these are the ones that you're going to shade in. And if it does work, then you know you're shading in the middle part. So let's just test a number in between -5 and 6. And I like to test 0 if I can, because that's so easy. So I'm going to test x equals 0. So that means x squared minus x minus 30 is less than 0. If these are all zeros, then this goes away, this goes away. -30 is less than 0. So this is true. So this part in here is shaded. And then when that's true, your inequality notation will have only one variable, no or in it, and it's going to go from your lowest number to your highest. Lowest number is less than x is less than 6. Now, if we had a less than or equal to sign, then that would change that, right? But we don't in this problem. So our inequality notation would look like this. Our graph is going to look like this. And that was pretty straightforward. All right, the last one I want to do is a little weird, and I don't want it to throw you. We're actually going to be given a problem in factored form. So it looks like this: x minus 1, x minus 3, and x minus 5 is less than 0. So what happens here, it's already factored. We're just going to say x is 1, x is 3, and x is 5. Well, look what happens on our graph. 1, 3, 5, and then the graphs go off to the end, right? So we have a dot here, a dot here, and a dot here. And now you're not just going to have one section that's going to get plotted. You're probably going to have a couple. So we're going to do a test in here. We'll test 0. So these are going to be our test values. Test 0, 2, 4, and 6. Okay? So let's test x equals 0. And we have x minus 1, x minus 3, x minus 5 is less than 0. So we're going to plop 0 in for all of those. 0 minus 1 is negative 1, minus 3, minus 5. And then this would give us 3 times negative 5 is negative 15 is less than 0. And this is true. Excuse me. So this part of this graph is going to be true. All right, now what I'm going to do, I'm going to erase what I have here in purple and just replace it with the next value for each of these. You should have all 4 on your paper, but I want to make sure we have everything in our vision of sight. So I'm going to erase this. And the next one we're going to test is going to be x equals 2. So now I'm putting 2 minus 1, 2 minus 3, 2 minus 5 is less than 0. 2 minus 1 is 1, negative 1, negative 3. This is negative 1 times negative 3, which gives us a positive 3, and that is not less than 0, so this is false. So that area in here, this guy is false. So no shading in there. Okay. Now I'm going to essentially go back and test these other values. So I'm going to erase again. I'll do this one in a different color. I'll do this one in green. So we're going to test x equals 4. So I have 4 minus 1, 4 minus 3, 4 minus 5, less than 0. 3, 1, negative 1. So this is 3 times negative 1 is negative 3 is less than 0. And this is true. So the 4 is a true value, which means this part is going to get shaded in here. Okay. And then let's go and check out our last value. And I know this is a pain in the rear end, but you know, sometimes life's not easy. Things happen. You're going to have to take some time, have some grit, work it out. So test x equals 6. So we have 6 minus 1 times 6 minus 3 times 6 minus 5. So this is 5 times 3 times 1 is 15. And this is false. And so everything up here is false. So that would not get shaded. Now, I'm going to, again, erase and just show the inequality notation. Okay, so you should have all that on your paper. We've tested all of our values. And we have to write our inequality notation. And we have 2 parts of shading on the graph. So that means we need 2 parts in our inequality notation. Okay, so the first one, the purple one, is going to be x is less than 1, right? Period. X is less than 1. Everything less than 1 over here is going to satisfy this equation. However, we also have this section in here. So we need an or. And then because it's between two dots, we have 3 is less than x is less than 5. The lower number, the higher number, the variable in the middle. And that's how that would look. So all of this would go into your inequality notation box. And I would just use the keyboard. X less than 1. The less than and greater thans are next to the M, kind of above and to the right of the space bar on your keyboard. And then you have 3 is less than x is less than 5. And you can just type. And then or with no spaces in here. So if you were to type, you would go x is less than 1 or 3 is less than x is less than 5 with no spaces in varsity. Okay, that's the last section in this chapter. So we'll next have a chapter review and a chapter test after we get this homework done. And then on to chapter 4, which is rational equations, which you're going to love because it's all fractions. That makes me excited. Makes you guys not excited. It's whatever. All right, toodaloo.